textbook reference, that's a reasonable textbook reference. At one point I will probably have you do some of the illustrations out of 19. That's, for some people, it's really useful. Okay, so moving right along, we're into ecology now. And you don't have to write all these down, but I want to talk about them with you. This is learning goals for the chapter. So, some of these learning goals are going to expand beyond this chapter. But the big idea for ecology is how living things interact with their environment, with the living parts of their environment, with the non-living parts of their environment. We are going to look at interactions you never even dreamed of. So that's a big one. We're going to talk a little bit about how matter and energy move through the environment. You have probably moved matter through the environment today. I know I have. I had some yogurt, 4th period, because it's my planning period. I moved matter into my own body. We all move matter right back out of our own bodies. You can figure out which part that is. And we move energy too. So matter and energy both move through the environment. We're going to look at this concept of energy storage. We do store some of the energy that we pull in from the environment. A lot of it gets lost. And that goes also for all the other living things in the environment. And we're going to talk about how distribution and abundance, where living things are at, how many living things there are in an ecosystem, has some limits on it. You can't have unlimited things in an ecosystem. There are limits. And it comes really down to available matter and energy and space. So that's the big picture goals. And like I said, some of these will more or less fulfill in this chapter, but a lot of them we're going to kind of keep working with. So with that, let's look at this big pretty ball here, the big blue marble. Don't even. All living things on Earth are called the biosphere. So if we take every living thing on the planet, and that includes animals, plants, bacteria, little tiny one-celled organisms that are eukaryotes but still one-celled, the protists, all that stuff, that's the biosphere. So sphere means a round, three-dimensional object, and the biosphere is the ball of living stuff. It goes up into the atmosphere. How far up do you think there are living things? Up to the very edge? So the farther up you go, I mean, you go through tremendous temperature changes, you go through pressure changes, the air gets very, very low density, very thin. How high do you think birds can fly? Do you think that they can fly up to like 30,000 feet where airplanes cruise? No, they can't. But you know what is up at 30,000 feet where airplanes cruise? Atmospheric bacteria. Bacteria actually can, the little bacteria, they're everywhere. Bacteria can actually form seeds for condensation. So to condense from a vapor, you have to have a surface to condense on. And bacteria can actually provide that condensing surface, that they call it a seed. How far down do you think there are living things? Okay, so aside from what was the article I just heard on the radio about biologists who were studying, it was some little rodent species, and they're having to take cameras and shove them down burrows, and these things live like 40 feet down below the ground, and they bite. So, half of the camera runs end with and the camera getting chewed on. Because if something comes shoving its way down into your home with a little light on it, you might bite it too. I forget, I need to find it, but it was some little endangered mammal species that makes burrows 40 feet down. They were trying to get counts on them. They were trying to, they burrow really, really deep, and they were trying to estimate the population size. And one way to do that is to shove a camera in their burrow and literally count. Interestingly enough, that's a great question. Does temperature change with your depth into the earth? Yes, it does. Eventually it heats. First, it gets to what we very often call earth temp or cave temp, which is about 55 degrees. So 55 Fahrenheit is, is it cold? Well, it's not freezing, but it's definitely chilly. You want a jacket at 55, but your water bottles aren't going to freeze. So, a 55 degree day outside, you're probably going to put on a t-shirt and a light jacket. So it's not that bad. Yeah, if you go down, once you get down about 2,000 feet, it starts to actually warm up. And I got to go in a salt mine at a lake area that was 2,000 feet down, and it was very pleasant. It was in the 70s, so 60s, 70s. But it was dry and pleasant. It was cool. So anyway, how far down are there living things? So, okay, we've got these little bitey rodents 40 feet down. Do you think there's stuff 2 miles down? What if we count the bottoms of the ocean? Are there living things at the bottoms of the ocean? Yeah. Yeah, absolutely. And there are soil bacteria pretty far down. Now, off the top of my head, I do not have a number. I don't know how far down in the soil column you find bacteria. I don't know that. It'd be a great thing to look up. I wonder how far down in the soil column do you see bacterial communities? I don't know. Well, anyway, let's look at what the biosphere would look like if we sort of imaged it. So I tried to draw a little spherical object here. That's my spherical object. And that little tiny, so the dark line in the center, you can imagine that that's the surface of the Earth. This is totally not to scale, because if you look down below the surface, yeah, there's a depth below which you still have living things. And if you look above it, up to, 30, 40,000 feet in the atmosphere, you still have living things. That sounds like a lot to little surface-bound critters such as ourselves. That ain't nothing. We are a critter. Of course we are. That's nothing, kids. It's like the skin on an apple. It's not a whole lot. The biosphere is this little skinny, I like to imagine it as green, even though we're not green, but this little sort of wiggly, squirmy skin on this giant rock hurtling through space. Do you feel less significant now? Do your problems feel smaller? I hope they do, because you're just one of the squiggly critters clinging to the ball of rock, hurtling through space, going about your life, doing your thing. We are all the central character in our own story, and that's good, but never forget that all the other actors think that they're the central character as well. So, now, we call that whole thing the biosphere, all living things on the planet. And we can talk about the hydrosphere, which is all the what on the planet? Water. We can talk about the geosphere, or lithosphere, which is all the solid bits, the rocky stuff. But we're focusing on the biosphere because we're in biology. So with that, what I would like to show you is this beautiful, gigantic greenhouse. Isn't that pretty? This sits out in the deserts of Arizona. If you ever get a chance to go to Tucson, Arizona, you can go tour this. This sits on the backside of the Santa Catalina mountain range. I lived for about a year up here. That's Mount Lemmon, one of those peaks. I don't know which one. One of those is Mount Lemmon, and I lived up there in a little tiny cabin. I had pack rats living in my silverware drawer. That was kind of gross, but it was also cool because, pack rats. And you could drive down the backside of the mountain. There was a crazy little road that went all the way down the backside, and it would spit you out in the town of Oracle, Arizona. And Oracle, Arizona sits in the high desert, so it's at about 4,000 feet above sea level. It's very, very dry. It is sunny, well, pretty much every day of the year, which if you are from this part of the world, for me anyway, just irritated the living crap out of me, because I needed a gray, rainy day where I could make a pot of soup and read a book. And there are no gray, rainy days. They don't happen. You wake up every morning, and it's bright blue and sunny. And you wake up the next morning, and it's bright blue and sunny. And I just wanted to import rain clouds. But that's another matter. So it's this bright, sunny, beautiful, high desert setting, and they built this crazy greenhouse. And they called it Biosphere 2. Why Biosphere 2? Yes, there is. Thank you. Yeah, you're part of Biosphere 1. You and me and the maple trees outside and the bacteria in the soil and the earthworms that are, dormant underground right now and all these plants, those are all part of Biosphere 1. Biosphere 2 was a manufactured attempt to create an artificial biosphere. And it was originally run by the University of Arizona, which is in Tucson, and it failed. I'm going to tell you that. So they took, I think it was 9 biospherians, bionauts, I think they called them, like astronauts, and they locked them in there. And there is, you can't really see it from here, but I think this is the rainforest, and there's an artificial ocean, and there are different biomes. There are places where they were growing crops. There's all this stuff, and these 9 people were going to live in there for 1 year without coming out. They sealed in all the oxygen and carbon dioxide, and they balanced all the gases. They had an atmosphere in there, and it was sealed. No way in, no way out, nothing. For a year, that was the plan. 3 months in, it failed. Nobody died. Spoiler alert, they didn't kill the bionauts. They imported oxygen. What happened was oxygen levels dropped precipitously low. And if anybody here has ever had a really awful case of pneumonia or a bronchial infection, asthmatic, really prone to them, where you aren't getting enough oxygen, your blood oxygen gets really low, it's really hard to move around. It's really hard to do anything when your blood oxygen drops. I know I'm really sick when I stand up and I go, oh yeah, I'm all prickly, I'm going to sit back down. I have low blood oxygen and I know it. So the oxygen in the whole place dropped. They couldn't function. And rather than letting the bionauts die, sorry, you signed up for the experiment, tough luck, they did import oxygen. Now, I'm not going to tell you why it failed yet. It's an amazing thing. If you go out there, it's now operated by a private company, and you can tour it. I think it's 10 or 15 bucks to get in, and you can go see the whole thing. They are still conducting limited experiments in parts of the biosphere too. But you're going to attempt to design your own biosphere too. Whoa! So I gave you a little bit of information, both with the picture. Note that it looks like a giant greenhouse, doesn't it? It really does, huh?
Weird castle.
It does look like a weird castle, yeah. It's very, I think the architecture, they built this in the early 90s, and they were trying to go for some sort of like strange, modern, I don't know what they were going for. But notice that all of this is all glass top. So it's letting sunlight in. Sunlight was the one thing that was coming in from the outside. This, I will tell you, was the rainforest. I know that. And if you look, you can see that there's green behind those windows. I don't know where the ocean was. I don't know where the crop areas were. I never went inside at the time I was living there. I don't know, I just never made it there. But anyway, when you pull up Classroom, what you're going to find for your assignment is basically instructions for making a biosphere 2. So you're going to have to think about all the living things you need in your biosphere. So they didn't just go in, just the humans. Humans can't survive by themselves. There were other living things in there. So what other living things need to go in there with you? And what kind of wastes will they produce? What kind of waste do you produce? Everybody here poops. Yes. There's actually a children's book called Everybody Poops. It's fantastic. It's the kind of thing you get to read when you have a child. It's totally worth it. It's worth every middle of the night wake up ever to have a copy of Everybody Poops at Your House. But, so there's that kind of waste. Anybody generating some waste right this instant? I am. What? What? Yeah, I'm breathing something out. What gas am I breathing out? What gas is it? Carbon dioxide. So, do all the other living things in there also put out waste? Yeah. So your assignment is going to be to think about a comprehensive list. When you pull up the assignment on Classroom, you got somewhere between very little and a whole bunch of guidance. And I'm going to give you about 20 minutes to get a preliminary idea. Now, you don't have to do like architectural designs or anything. I want you to be thinking in terms of the functional stuff. Then we'll share our ideas. Then I'll tell you why they failed. And see if your biosphere is prone to the same thing.